All right, now we're going to do some more practice. This time I actually want you to copy this one down as we work through it. What?
That's a lot.
You think that's a lot? You should see some of them. All right, so we're going to work on the fraction 4/7. Okay, remember, we're trying to, well, is it a rational number? How do we judge if this is rational? Josh.
Both are good. The top number is
an integer.
Integer,
good.
And 7's an integer, and it is not 0.
Good.
So that means.
Is it rational, everyone?
Yes.
What would happen if the 7 were a 0? It would be irrational, first of all, because it doesn't exist. Yes.
Oh.
Your mom or dad has never told you you're being irrational.
No.
You're clearly not my kids. All right, so we take our rational fraction 4/7, and again, we set it up correctly. Make sure you see that the 7 is the divisor. Look at it here. Here it's the denominator. It becomes the divisor. And the 4 is the numerator. That becomes the dividend. That's a tricky part of this. Here's a trick that I use to remember how to set that up. I look at the fraction, and I draw my little house out here, and then I take the top number and I put it in the house. And that's how I know how to set up. 4 divided by 7 looks like 4 divided by 7. Divisor or dividend. Everybody see that? Make that note first. How to go from this to that. The numerator always goes into the house, yes. Sometimes you might see this as this. Sometimes you might see this as 4 divided by 7. And the same thing, 4 and 7. Okay, all three of these are the same exact problem. You have to know how to write them appropriately.
Why is all division so hard?
We like to do things the hard way because we're old. Back in my day, we had to do this on no paper and pencil. We had to chisel it into a rock.
Back in the Stone Age.
I used to have to make my own papyrus.
What was that?
It's a kind of paper that the
Egyptians use that?
yes, they did. Good job. You people
Yeah, Miss
paid
Groff.
attention. Who was your social studies teacher last year?
Groff.
Way to go, Miss Groff.
Miss Min. Yes, Miss Min.
Miss Min.
Who's Miss Min?
She wasn't like an assistant teacher. She came in and then she left and she came back in and she left. She knew she was a ninja.
I love Miss
All right, so here we go. Old people division, step 1. Gazinta.
Gazinta.
All right, calm down a little bit. We asked 7 gazinta 4. How many times? 0. 0 times 7 was 0. We subtract and we got 4 as an answer. Bring down the number. That's the first cycle through those rules. So do that first, that part first.
I just copied it.
Well, make sure you understand. It's not just about copying right now. I want you to actually do it step by step by step with me. Okay, so if you just copied it all, do it again. Oh. So 7 goes into 4 0 times. 0 times 7 is 0. Subtract, we get 4, bring down. That's the first run through of our 8 steps. And then we go back to step 1, gazinta. 7 gazinta 40, 5 times. 5 times 7 is 35. I do my subtraction. Here's that check I was talking about. The answer to my subtraction was 5. If that answer were more than 5, then the 5 would be wrong. If I only put a 4 there, I would have to bump it up to 5. So the answer can never be bigger than your divisor. Run through the whole process again. I got 5, I brought it down. 7 goes into 50. 7 times 7 is 49. Subtract, I get 1. bring the number down. I have 10. 7 goes into 10. 1 time. 1 times 7 is 7. Do my subtraction, I get 3. Bring a number down. 7 goes into 30. Where am I? 30. 4 times. 4 times 7 is 28. I subtract, I get 2. I bring my number down, I get 20. 7 goes into 20 2 times. 2 times 7 is 14. I subtract, I get 0. I bring down the 0. 7 goes into 60. 8 times, 7 times 8 is 56. I wrote it down there, but it got too low for you to see, yes.
I don't get what 10 meant. Like, where do you get 7 from?
I asked myself, how many times does 7 goes into 10? Goes into, you see it goes into 1. It can't go twice, because that would be, so it goes in 1 time. So that 1 goes up here, and then I do 1 times 7 to get that 7. See it? Good job for asking. Now, this number starts to repeat. After I do that 60 minus 56, I get 4 as an answer, and I add another 0, but I ran out of room, so it's continued on the next page, but just the answer part. Okay? So I'll let you get down to, anybody need more time getting to this point? Okay, keep going. Yes? It's 56, because it went 8 times, and then 8 times 7 is 56. I'll get 4 as an answer, and then we'll continue on the next page. Yes?
You don't need to add another 0, right?
We're going to keep adding zeros until we're done. Okay? So here we go. Who's up for the challenge?
Not me.
Oh, yeah.
No, thank you. I'm up for the challenge.
So we had 4, we added a 0, brought it down, and it went in 5 times. And then we did 5 times 7, 35, subtract it. We got 5, we brought a 0 down, and then it went in 7 times. 7 times 7 was 49. It never, ever, ever is anything different than 571428, 571428. 571428, 571428, 571428, 571428, 571428, 57142, 57142, and you can continue this problem forever, and you will never be finished if you work your entire life, every minute of the day, and then everybody else's life in the whole world. It goes on to infinity. So rather than torturing you like that, I'm a kind person. We give you an out. We give you a shortcut, and we simply say, if it starts repeating, and that's what it's called a repeating decimal, then you can put this bar over the top, and then you can be finished. Once you see the repetition, you don't have to do it forever, because we're nice. Okay? So this is called a repeating decimal. Make sure you take a note of that. After you get through the, oh my god, okay, we don't have to do it forever. If it's a repeating decimal, put a little bar over it. Make sure you put that in your notes, Reed. If it's a repeating decimal, in other words, it repeats over and over and over again, then you can put the little bar. Christina? No. I mean, you know, that's for dramatic effect. So you really see. Calculators are not really that smart.
How long did you copy and paste?
Why would I copy and paste?
How long did it take you? You copied and paste. I can see why the 2's in the 8's.
Yeah, this whole section is copied. But I did the first 2 lines.
Yes.
See it?
Yeah, it's all.
All right.
Wait.
Okay.
What if the decimal only repeats like 2 times? Yeah.
So it's like 0.25, 25, 25?
Yeah.
You just put a line over the 25. You put a line. That was a great question. What if the number of decimal points repeating is only 2? Then you just put a line over the 2 decimal places that repeat time in. Sometimes it'll be just a single decimal will repeat. Okay? Like 1/3 is going to be point what repeating? 1/3 is going to be, it'll be 0.33333333333333 forever. It'll never change. So instead of making you do that, you put the little bar over the 3. All right. Now we can use this technique, this long division, this old people Gazinta way of doing things, in order to compare fractions. Okay? So if I want to say 4/5 or 8/9, which is bigger? I do my long division for 4/5 and I got 0.8. And then I did my long division for 8/9 and I got 0.8 repeating. So now I can use the decimals to see which is greater. So over here I said, since 0.8 is less than 0.8 repeating, 4/5 is also less than 8/9. Everybody see that? You need this part, and then just know that we're going to use that process. You don't have to copy this part. And then I'll tell you about the calculator. So just kind of the top part, and then we're going to do more practice of those. So this is like the title. And then you're going to use old people Gazinta-ing.
No.
Because it's just fun.
No.
Yes. Yeah. I'm having so much fun. I can barely control myself.
I'm glad. Although don't get out of control. Okay. You don't have to write this part down. I get a little freaked out over this, but you have to know that calculators are great, but they're stupid. Stupid. They know nothing. Okay, you know more than this calculator. You have to believe that. You guys know, I believe, that if I did, oh, who knows? Oh, well, that one, let's do 2/3. If I were changing that into a repeating or into a decimal, I would do 3, 2, nope. I would do 3, 2. 3 goes into 2, 0 times 3 is 0. Do my subtraction. 2, add a decimal point, add a 0. Notice, I probably didn't say that enough, but make sure you put that decimal point in your quotient. Once you put it after the 2, it goes directly above in the quotient. So to bring that 0 down, 3 goes into 20. 3 goes into 20. 6 times 3 is 18. Subtract, I get 2. Add a 0, bring it down. At this point, we start to see that that 6 is going to repeat. Right? Well, that 6 will repeat forever. You know that now. 6.666666666. Will I ever be finished?
No.
Never, ever, ever, right? So again, we have that way that we can do 0.6 repeating. Your calculator can't. Your calculators do not show you it's 0.6 repeating. Instead, they get the problem wrong and do 0.666666, and then at the end they put a 7. And they don't tell you that's an approximation. They don't tell you I just rounded up on that. They say the answer is this. It's impossible. It's wrong. Look at this. Look. 2 divided by 3. 0.666666667. No, you can't get a 7 after all these 6's. It will never change. Every time I do the subtraction, I'm going to get a 2. I'm going to break down the 0. I'm going to put a 6. I'm going to get a 2 again. I'm going to put it will never change. It's stupid. You have to be smarter than the tools. So here's what you need to know. Use it, but you need to know its limitations. And it's limited. So don't think that that is the exact answer. You have to be smart enough to know that it approximated it or it rounded up, because it didn't want to do the same problem for the rest of its life either, and it doesn't have a way of putting the little lines. So be smarter than the calculator, right?
Right.
You see how woo I get? So don't make that mistake, or I might go woo all on you. I don't know what that means, but I'll be like, I don't know, calculator band. Okay? Any questions on that? All right, there's some great practice on page. I don't know. The bottom of page 17, please. Numbers 1 to 4. Bottom of page 17, numbers 1 to 4.